look at solving 1- and 2-step equations. So this is something that we have done already, but just not formally introduced yet. So hopefully this won't be something that's too crazy for you. So to solve an equation means to find the value of the variable that makes the equation true. So that means the value that makes the left side equal to the right side. For other equations, the solution might not be so obvious, but for these equations, we use the opposite operation to isolate the variable. So basically, when we're solving equations, we just want to balance the equation so that the left side is equal to the right side, and we'll go through a couple examples with that right now. So the first example is we're going to solve for x here. So we have x plus 7 equals -8. So I'll show you a couple ways to do this question, and then you can choose whatever way you feel most comfortable with. So what we want to do is we want to get this x alone. We see here that 7 is being added to x, so we actually want this side to be 0. So if we take away 7 here, we're going to actually take away 7 from the right side of the equation too. So what we would be left with is x is equal to, because this positive 7 take away 7 equals 0. And then when we have -8 minus 7, we are left with -15. So this is one way that you can solve the equation. Another way would be simply to take this positive 7 and send it over to the other side of the equation. So in doing so, we would have x is equal to, so if you take this -7 and you send it across the equal sign, you have to change the integer on it. So it's positive here. We would have to take away 7 when we send it over, and we would be left with x is equal to -15. So two ways basically arriving, well, you're definitely arriving at the same answer, but you're essentially doing the same thing. So for this example, I'm going to do it our second way that we did it here. So I'm going to take this -12 and I'm going to send it over to this side of the equation, but I'm going to change that integer sign and make it positive. So when you move something across the equal sign, it has to be positive. So for this question, we're left with x is equal to 19. So we're doing the opposite operation. So in this question here, it's an addition, but we're actually moving it over to subtract the 7. Here we've got a subtraction, but we're moving it across the equal sign to do the opposite operation, which is addition. So if we have something that's being multiplied, the opposite operation of multiplication is division. So we're going to divide out whatever that coefficient is. And if you remember, the coefficient is the number before the variable. So if we divide out the 3 from the left side, we're going to divide out the 3 from the right side. These 3's cancel out because it leaves us with 1. So we're going to have x is equal to 9 for this example. So at the bottom here it says to check. So when we do a check, we're basically going to do a left side, right side check. So I'm going to add 2 columns, oops, and we just need 1 row, 2 rows. Let's do 2 rows. Well, that's just 1 row. But I want to it's not ideal. Okay, we're going to just do the check here because we'll do it here. So for a check, it's left side, right side. So we're just going to write left side here, and then we're going to write right side here. So on the left side, you're going to take your equation just as, see, this is why. Let's delete that. We're just going to cut that out. Maybe. I'm just going to move it out of the way so we don't have to look at it, and then come back up here. So for the check, you're going to have left side, and then you're going to have right side. So for the left side of the check, you want to take the equation exactly how it looks. So you're going to have x plus 7, and then on the right side of your equation, you're going to take exactly how it looks on the right side of the equation. So there's just a -8 on the right side of the equation. So this is the benefits of learning online, is that my daughter presses her princesses and you get to hear the Jasmine song right now. So as we're learning, please bear with the music. Oh, she turned it off as she gave me a dirty look. Oh. So on the left side check, so what we've done is we've put the equation exactly how it looks on the left side, and then we've put the equation exactly how it looks on the right side for our check. So here you're going to sub in the value that we calculated for x. So we said x was equal to -15, and then continuing with your equation there, you're going to add +7. Your right side is already in its simplest form, so we can actually leave that as it is. And then we solve the left side of the check. So -15 plus 7 is -8. And this is equal to the simplest form on the right side of the check. So therefore, left side is equal to right side. So when you do a check, it needs to be in a chart form. So this is why I drew it in. I tried to do the chart, but we remember what happened there. So when you do left side, right side check, it's a T chart. You do not put equal signs. The equal signs come at the end when you confirm that the left side in fact is equal to the right side. So if we were going to do a check for part B, we would have x minus 12 on the left side. So the left side would be x minus 12. The right side we'd have +7. You would substitute 19 in for x, subtract 12, and then you would find that that's 7. Confirm left side equals right side. A check for this question, you would sub in, I have room, let's just do this one. Left side, right side. So here on this side we have 3x, and on the right side we have 27. So here I'm going to sub in my 9 for x, 3 times 9, and that is equal to 27. So therefore, left side is equal to right side. So we confirm that check there. So this, you just need to be aware that this, if a question's asking you to check, you need a structured check that looks like this. No equal signs, and use the T chart. So let's solve these equations. So here we see 13 is equal to -5m. We want m isolated. We see that there is a coefficient on the m that's being multiplied. So we just divide out that coefficient, -5. So the answer to this question is 13 over -5 is equal to m. So here it doesn't matter if your negative is in the numerator, it doesn't matter if it's in the denominator, it just has to be there. So recognizing that we're isolating by division. So this question, W over 4 is equal to 18. This W is being divided by 4, so we're going to multiply it by 4. So if we multiply this by 4, we're going to actually multiply this side by 4 as well. These 4s would cancel out. We're left with W equals 72. Another way to do this question would be to cross multiply. So if we see that there's a 4 in the bottom, in the denominator, we just multiply it up to the 18. And we've done stuff like that before. You still get the same answer. The marking in blue shows the theory why we're just multiplying it by 4. So we're not cross multiplying willy-nilly. We're doing it because we're multiplying both sides by 4 in order to isolate this variable. So this question, we've got negative 3 plus x is equal to 10. So what I'm going to do here is I'm going to take this negative 3 because I want x to be by itself, and I'm going to send it over. So I'm going to have a line of x equals 10. And remember, when we take a negative across the equal sign, we change the integer to become positive. X equals 13. So looking down at part G, you've got to move this stuff away from the variable first. Anything that's not attached by multiplication or division gets sent over first. So if we send that negative 8 over, we're still left with our 2m here is equal to 10 plus 8. Remember changing the integer sign. So 2m is equal to 18. And then here, we isolate the variable by dividing by 2. So if we divide this side by 2, we divide the right side by 2, m is equal to 9. This question, we're going to send the 5 over. So this question's kind of interesting because we're going to have m alone, but it's negative. So don't forget about that negative m. And then we're going to have negative 4 minus 5. So negative m is equal to negative 9. But we can't have the variable negative at the end. So we assume that because this is negative, it's a negative 1 that's in here. To isolate m, you do the same thing that you would if it was a different number than 1. You divide by the coefficient of negative 1. So this would leave us with m is equal to 9. Lastly, this question, remember you want to take away the stuff that's not attached by multiplication or division first and move it away from the x. So here we have x over 2 is equal to 11 plus 3. X over 2 equals 11 plus 3 is 14. And here we're going to cross multiply this 2 up to get it out of the denominator. And we'll be left with x is equal to 28. And for any of these questions, you can do a left side, right side check by just subbing in whatever number you find for your variable into the equation and solving it. So checking your solution, you can always check your answer by substituting. So that's basically what I just said. Substituting the value of the variable back into the original equation. The left side and the right side must have the same value when you're done solving it. So this, we're going to check that x is equal to 8 is the solution. Just a side note here, the root of the equation is the same as asking you for the solution. So if you see in your textbook it says solve or find the root of the equation, it's basically asking you to solve for the variable. So if we're doing a check here, we're going to set it up again, left side, Right side check. Remember, we're using a t-chart. We're not using equal signs. So the left side of the equation here has 2x minus 7, and the right side is 9. So the right side's already in its simplest form, so we can just leave that as a 9. Here it says the solution is 8, so we're going to substitute in, I'm not sure why that looks like that. We're going to substitute in 8 for the x. I'm not sure why this is not writing very well right now. Maybe it's me. Multiply that out, 16 minus 7, and then 16 minus 7 equals 9. So therefore it's confirmed that left side is equal to the right side. So there is a check for you. Just make sure you're substituting. Literally, when x is equal to something, wherever you see an x, you put that solution in when you're doing a check. So the last question is, as a producer of Canadian Superstar, your first task is to rent the theater for the singing competition. Rental includes lunch and snacks for the competition. Broadway Nights Theater charges $1,000 plus $30 per person. So write an equation to model the cost for renting the Broadway Nights if N represents the number of contestants. So we're going to write an equation in the form of y equals mx plus b. So in terms of cost, so cost becomes our y. So we want to know what the total cost is for renting the Broadway Nights if n represents the number of contestants. So n is going to become our x variable. So we've got c equals something n plus something. So we have to fill in what our m value would be and our initial value would be. So Broadway Nights charges $1,000 plus $30 per person. So if the initial charge is $1,000, that's like saying the initial value is $1,000. So that means that initially we are going to be charged $1,000. This is our b value. This is where if we were to graph it, our line would cross the y-intercept. This $30 per person, because it's per person, it's a rate of change. So that should signal that would be our slope, because slope and rate of change are interchangeable as terms. So if we're modeling this equation, we've got the total cost is equal to $30 per person plus an initial fee of $1,000. So if there are 25 contestants, what would the rental cost be? I need a bit more room. So $30 or 25 contestants, we're looking for the total cost. So 30 times 25 plus 1,000. So in the essence of time and keeping this video shortened and the fact that I can't write very well with this, I'm just going to solve this for you. You can check it on your own. The total cost would be $17,050. So here you would write your therefore statement. Total cost is $1,750. The last question here says, if you have a budget of $2,000, how many contestants can you have? So if our total budget is $2,000, that means that we can only spend $2,000. So we're trying to find the number of contestants. So our rate of change stays there. Our number of contestants is unknown, and we are looking for or we are using our initial value of the $1,000. So in order to solve this, you are going to take this $1,000 and move it to the other side of the equation, because remember, we want to leave everything that's attached to the variable at the end. So you're going to have 2,000. You know what? I'm going to type this one in. So you're going to have 2,000 minus 1,000, which is equal to 30n. So 2,000 minus 1,000 would give you 1,000, and that would be equal to 30n. So in order to solve the rest of this, we would have to divide out that 30 from both sides to isolate n alone. So 1,000 divided by 30 is 33.3 equals n. But wait a minute, you realize you can't have 0.3 of a contestant, which is a person, so you need to round this. So we can't have more, so we definitely only need 33 contestants. So therefore 33 contestants, and you would write this in a full sentence. 33 contestants are the maximum number of people you can budget with if you have a budget of $2,000.